All right, let's dive in. Today, we're pulling back the curtain on the secret language of the universe. I'm talking about a set of rules so basic, so fundamental, that it shapes every single physical law you can think of, from a simple falling apple all the way up to a spinning galaxy.
So get this. It sounds like a superpower, doesn't it? Being able to glance at an equation and just know, nope, that's not right. Well, by the end of this, you're going to know the secret too. We're going to solve this exact mystery, and the answer is all about understanding the grammar of reality itself.
Okay, so before we can get to the rules, the grammar, we need to know what our words are made of. And the very first building block is something we call a physical quantity. This is basically the stuff physics can actually talk about.
Now the key word here, the most important word, is measured. See, physics is a science of measurement. If you can't put a number on something, you're not really doing physics. It's kind of that simple.
And this right here just illustrates the point perfectly. Your weight, totally measurable. That's a physical quantity. But your feelings for your crush, good luck assigning a standard unit to that one, right? So, yeah, physics deals with a measurable world, not the mushy stuff.
And this brings up a really crucial point. A measurement is never, ever just a number. If I told you I weigh 70, that means nothing. 70 what? Ounces? Stones? Kilograms? That number, the 70, gives you the amount, but it's the unit that gives it actual physical meaning.
So let's see how this all builds up. It turns out that every single measurement we can make in the entire universe, I don't care how complicated it is, can be broken down into just 7 fundamental building blocks. It's like we found reality's primal alphabet.
And here they are, the magnificent 7. Everything from the energy in a star to the charge of an electron is just some combination of these. But don't worry, you are not going to have to memorize this whole table today.
For what we call classical mechanics, which, describes how most everyday things move, we only really need to master the big 3. These are the absolute cornerstones of the whole system.
First up, we've got mass, which we represent with a big capital M. This is the how much stuff is in it dimension. Doesn't matter if we're talking about a planet or a proton. Next, there's length, with a capital L. This is our how much space does it take up dimension. This covers everything from the distance to the next galaxy to the size of a single atom.
And finally, we have time, our capital T. This is simply the how long did it take dimension. That's it. Mass, length, time. M, L, T. That is our entire alphabet for today.
So, now we have our letters M, L, and T. The next step is to learn the grammar. We need the rules for how you combine these letters to make meaningful words, which in the world of physics are things like velocity, force, and energy.
And this is our main tool, the dimensional formula. Think of it like a recipe. It tells you exactly which fundamental ingredients, M, L, and T, go into any physical quantity and how much of each you need.
Let's try a really simple one, velocity. We all know velocity is just distance divided by time. Well, distance is a length, L, and time is, time, T. So the dimensional formula is just L divided by T, or L times T to the minus 1. And see how we write it as M to the 0? That's just a clean way of saying mass isn't involved here at all, because anything to the power of 0 is just 1. Now listen, if you only remember one single thing from this entire explainer, please make it this, the dimensional formula for force. It's mass times length divided by time squared. This is the master key. Seriously, so many other important quantities are built using force, so knowing this one unlocks a huge chunk of physics for you. Okay, here we go. This is the big rule, the absolute core of our grammar. It's called the principle of homogeneity, which sounds super fancy, but I promise you, the idea behind it is incredibly simple. You already know it. I mean, think about it. You would never add a weight to a length, right? It makes no sense. It's like adding apples and oranges. Well, guess what? Physics equations have to obey that exact same common sense rule. Every single piece of an equation that you add or subtract has to have the exact same dimensions. And that brings us all the way back to our initial mystery. This is the superpower. This is how it's done. You look at an equation, you check the dimensions of the thing on the left, then you check the dimensions of the thing on the right. If they don't match, it's fake. It's physically meaningless. Game over. But just checking if equations are real or fake, that's just scratching the surface. The truly mind-blowing part is that we can actually use this to derive the laws of nature, sometimes without doing a single experiment. It honestly feels like you found a cheat code for the universe.
So let's put this to the test. Let's take a classic pendulum. Let's say we want to figure out the formula for how long it takes to swing back and forth. All we know, or all we suspect, is that the swing time depends on the length of the string and the acceleration due to gravity. That's it. Can we build the real formula just from that hunch?
Okay, just watch this. It's amazing. Step 1, we just write down our guess. Time is proportional to length to some unknown power x and gravity to some power y. Step 2, we swap everything out for its fundamental dimensions. Now for the magic trick in step 3. Because of that principle of homogeneity, the dimensions on both sides must balance, so the power of time on the left, which is 1, has to equal the power of time on the right, which is negative 2y. And the power of length on the left, which is 0, has to equal the power of length on the right, which is x plus y. Step 4 is just simple algebra to solve for x and y. And then, step 5, we plug those numbers back in, and the law of nature just reveals itself. It's incredible.
Now, as powerful as this is, it's not perfect. It does have one pretty major limitation we have to be honest about.
Remember that little k in our final formula? That's a dimensionless constant. It's a pure number, no units, no dimensions. And dimensional analysis is completely blind to those numbers. It can tell us that time is proportional to the square root of length over gravity, but it has no way of knowing if that's multiplied by 2, or by 2 times pi, or some other pure number. To get that final little piece of the puzzle, you do still have to do an experiment.
So what have we seen? We've seen that the very fabric of our physical reality is built on a simple alphabet and a consistent grammar. It's a system that forces the language of physics to always make sense. That's a pretty profound idea, that the universe isn't just a random jumble of stuff, but that it's ordered and it's understandable. Which really just leaves us with one final thought to chew on. If physics has a grammar, what other hidden rules are out there, just waiting for us to discover them?